I'm Lily Jameson.
And I'm Dr. Ellie Jameson, and today we're going to talk to you about pH. So what is pH and why is it important? So scientists use something called the pH scale to measure how acidic or basic a liquid is. And the scale of acidity goes from 0 up to, do you know what number?
14.
14, that's right. So pH stands for potential of hydrogen, which isn't very helpful, it doesn't tell us much about it, but it's a measure of the concentration of proteins in a solution. So anything with a pH of under 7 on the scale is an acid. So acids are sour, and do you know what type of things might be acids, Lily?
Like lemon juice?
Yeah, lemon juice.
Vinegar?
Yeah, so things like that are acids. And really strong acids are lower, so closer to 0. And really strong acids can be dangerous, so we don't have very strong acids in the house. We've just got vinegar and lemon juice. But it can get very strong acids, and those ones can cause problems because they can burn you and they can melt through plastics and things. And then at the other end of the scale, at the higher numbers, so anything above 7 is an alkali solution or a basic substance. So these can be things like, do you know what might be alkali, Lily? Is there anything which, what's it make in liquids, alkalis? So it can be soaps and bleach,
yeah.
And it makes things go
Bubbly.
Bubbly, yeah. So alkalis can be bubbly things. And on this end of the scale as well, there can be some dangerous substances there. So bleach that you might use to clean the toilet isn't very good for us, and we wouldn't want to get it on our skin or in our mouths, and that's a strong alkali. So very strong alkalis can be a problem too. So we don't have anything stronger than bleach in the house for cleaning with. And even that we've got to keep really carefully and away from. So we can use bleach for cleaning. We can use acid compounds like vinegar to flavour food. But acids and bases, we use them for other things as well. So inside our body, they have important roles. So we have acids inside our stomachs. This helps. Do you know what that does, Lily, the acid in our stomach? Helps to digest and break down our food, doesn't it? And it might kill off some bacteria which aren't very good for us either. So some pathogenic bacteria it might kill. And also in our body, after food's gone through the stomach, the pancreas, which is another part of our body, helps to make an alkali, which helps to stop that acid going any further down. Because the stomach can cope with strong acids, like the hydrochloric acid, which is inside there, but the rest of your gut can't cope with it. So the alkali produced by the pancreas helps to neutralise that and helps digestion lower down in the gut. As well as using them inside our bodies, build-up of lactic acid in our muscles comes about when we use our muscles quite a lot. So if you've run really, really fast, or if you've been lifting lots and lots of things, your muscles might feel a hot, burning, uncomfortable feeling, and that's the lactic acid that's building up in there too. So we have those inside our bodies, but we can also use acids in batteries. So usually in a battery, you've got an acid and a metal, and the chemical reaction between those two makes electricity, and that's how we use them in batteries. You might also use them in industry as well. So in making paper, they use bleach to make the paper nice and white. So we use acids and bases in lots of different things. And also in a vitamin that we eat to keep us healthy, like vitamin C, that's an acid too. So we've got lots of uses for different acids. And today we're going to use cabbage water to try and work out if things are acids or bases. So we've got a few different things here that we're going to try out. We've got some cabbage water in these glasses, and we've got some vinegar. We've got some washing out liquid. We've got some baking powder, and we've just got some tap water. Yeah, so to each of these, we're going to add one of these liquids. So to the first one, Lily, we're going to add into this glass, we're going to add a bit of our vinegar. And what's the vinegar? Do you think it's an acid or an alkali? Do you know? Do you remember? Pour that one in there. Right, we stir it around with this spoon if you like. Do you think that's gone more pinky or more bluey? You think that's gone more pinky? So vinegar, do you remember if that's acid or alkali? So this is quite sour tasting, so this is our acid. So the pinks and acid colour. Right, now next up is fairy liquid. So you're going to just wash it up liquid. You're going to, no, we'll keep this one for the baking powder because that one needs a nice throw. You're going to tip a bit of that in there. Just a little bloop. Right, okay. And then, oh, that one's the acid spoon. So we want to see what this one is. So we use a different spoon. So stir that one around. We keep stirring that one afterwards as well. So is this one gone more pinky or more bluey? It's gone more purpley and bluey, hasn't it, that one? Okay, right, so we can take out some.
Is this the witch's brew?
No, that's not the witch's brew. We're going to make the witch's brew next. Right, so that's our vinegar. It's gone pinky. Here is our washing up liquid. That's gone purpley. So we know that alkalis are bubbly, so our washing up liquid has gone the opposite colour to the vinegar, so that's an alkali. Our washing up liquid. Next up is our witch's brew, as we like to call it.
Oh,
Yeah, just there we go. A nice big spoonful of our baking powder in here. So what's happening to it, Lily?
It's going.
I'll move everything out so that we can see. Is it going pink or is it going more purple? And what's happening on top of it? Foamy, yeah, it's got lots of bubbles in there, hasn't it?
Yeah.
And that's the reaction between our baking powder and our cabbage water.
Look.
So it's made loads of bubbles, hasn't it? So in baking, you can use the baking powder to make things light and bubbly.
Look.
So you might use that in scones to make them bubbly. Right, so is it purpley? Right, so should we use, right, and now the last one. Right, so I've got those ones. Next up is water. Oh,
Loads.
can't see again. Right. Too many things up. Right, next up is the water. This one's the water, and you're pouring in some tap water. Do you think it's changed colour much?
No.
Not much changing colour though, is there? So,
Mummy, can we?
oh yeah, and you can see this one. So this one is the one that we did before, isn't it? We poured everything into the same glass.
Yeah.
Did it go more blue?
Purple.
Yeah, it went more purpley, didn't it? So this is when we mix everything together, our baking powder, our vinegar, the water and the washing up liquid all together.
Oh.
Well, we're going to do that in a second. Then it went really purple. Okay, right, now Lily's going to mix together the water one with the vinegar one. Is it going to go more pink or more blue?
Pink.
Yeah, it's going to go pink because it's got more of the acid in it. Oh, next she's going to add the washing up liquid into our acid pinky one. And what colour is it going to go?
Purple.
It's kind of back to, is that back to, it's slightly more pink than it started off, but going back towards more. Right, now this one, our really bubbly witch's brew one, the baking powder. Add that one in. Oh, what colour's that one gone, Lily? So that one's got purple. So when we mix everything together, that must mean that our baking powder has taken up to an alkali in the end. Okay, so if you want to make your own cabbage water, we just took some red cabbage and we boiled it for about 10 minutes. We ate the cabbage and then we kept the cabbage water. You can also just blend up some cabbage and some water and just sieve out the lumps of water. And then if you want, you can make it into indicator paper. So if you soak some coffee filters in the cabbage water and then you let it dry overnight, then you can have a little piece of paper that you cut in strips and you can test if things are acid or not. Excellent. Have fun playing with your pH at home. Bye-bye.